Hello folks, this is 2025 May June paper 1-3 and the question number is 7. It is concerned with the chapter kinematics and related to projectiles. It says two coins are projected from a horizontal table at the same initial speed. Same initial speed. So something like this. So this is the edge of the table, and this is the manner of throwing coin is like this. One is like this, and one is like this. So yeah, point X is projected horizontally, so horizontal you can see, and point Y is projected at an angle of 30 to the horizontal like this, you can see, and both have got the same initial speed u. It is shown here. Both coins hit the ground without bouncing. Okay, assume that the air resistance of each coin is negligible. Okay, which statement about the motion of the coins is correct? So here, as you go through the choices, let us say, go according to easy things. So if I have to deal with choice A, it's a bit difficult. So let's go from choice B, C, D, and then we'll come back to A. So in choice B says that both coins travel the same vertical distance. So if I consider this as the as one of the foot of the table, this as the ground, so you will travel this thing will travel vertical distance like this. The vertical distance traveled by coin X, but the vertical distance traveled by this coin Y will be, it rises like this, and then comes like this. So the vertical distances are not equal. So this is incorrect. This is incorrect. So let me write this. Yeah, this is incorrect. Next is coin Y hits the ground before coin X. So this is a bit unrealistic because this X does not have to travel any vertical upward, so it just comes like this and hits the ground. But this thing has to go like this and then has to hit like this. So definitely this thing should require less time, and this thing should require more time because it has to rise up, and here only it is horizontal and then it falls. So that's why here it falls horizontally right from the beginning, but here it is only after some time. So some time lag has already happened there. So this should take more time and this should take less time. So that's why coin Y hitting before is untrue. Now number D. Coin Y has got smaller vertical acceleration. No, the vertical acceleration is here. What it is simply equal to Z, A equal to Z. So I can consider this as A G equal to G, and here it is A equal to minus G equal to minus G. So in that sense, the numerical value is same because it is affected by Earth's gravity. So again, this also untrue. And this makes us feel that the correct choice is choice number A, but let us derive it. So if I go through the calculations of velocities, it will take a long time. So what we do is, let us do it in terms of conservation of energy. So in the beginning, since the velocities are constant, K initial of both equal. And since they are at the same height, the potential energy initial is also both equal for both of them. Now, finally here, the PE final is equal to 0, equal for both. Now our equation A should be equal to, since energy should be conserved, what we must have is KE final plus PE final should be equal to KE initial plus PE initial. Now this is equal for both. This is equal for both. This is equal for both. So this also should be equal for both. So that means the coins are same. So K finally is equal for both. That means 1 by 2 mv square or u square. Or let's say v square should be equal for both. So masses are equal. So velocity also should be equal, or speed also should be equal. So that means that both coins hit the ground with the same speed. So choice number A is the correct choice.